Afternoon. Can you hear me? Hello? Very good evening. Good evening. Okay. So let's start with the very important module. That one is statistics. Statistics in data science, basically. So basically, you had already studied about the statistics during your Excel also. Good evening. Yeah. So here is also, in data science, we do use a lot of statistics also. So let's do certain statistics also here. So whenever actually we work on statistics, whenever we, good evening. Yeah, good afternoon as well. So whenever we work on statistics, so basically what is the statistics? You are already aware with the statistics. You did a lot of statistics during your, I'll say like here, during your Excel also. So basically, statistics is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist making more effective decisions. Basically, statistics is a bunch of mathematics used to summarize, analyze, and interpret a group of number of observations. So basically, when we talk about the statistics, you should be aware that there are basically two types of statistics. Statistics is categorized into two types: descriptive statistics, and inferential statistics. When we talk about the descriptive statistics, this one is a descriptive statistics. And there is the inferential statistics. So when we talk about the descriptive statistics, that is again divided into two. Okay, two categories are there. And they are central tendency and dispersion of data. When we talk about the central tendency, it means we are talking about mean, median, mode. So basically, central tendency means we are talking about the mean, median, and mode. Mean is the average of any provided number. So if we are having n numbers, if I am having 50 numbers, we can add all the numbers divided by total numbers. So add all the numbers divided by 50, we can do that. That one is a mean. Median is the centralized value inside the total set of numbers. And mode is basically the frequency of the number, the count of the number which is occurring number of times, the number which is occurring number of frequency of times. Means here, if any number I'm having 10 numbers, and if one of the number is appearing 5 times, so it means a number which is appearing the highest number of times, that one is the frequency or mode. So mean, median, mode are basically the central tendency. Now, when we talk about the dispersion of data, so when we talk about the dispersion of data, so it means we can talk about the range. Range is basically the difference between the maximum minus minimum here. We can have the variance also. Variance is again that how much is the difference between the point and any data point and the average. And we are having the standard deviation as well. So range, variance, standard variation, okay, range, variance, standard deviation. These are basically dispersion of data, and we do have percentile and skewness also into the data. It means here in central tendency, we are looking what are the mean, median, and mode of the data. And in dispersion of the data, it means how much the data is spread. What is the range? What is the variance? What is the standard deviation? What is the percentile and how much the data are skewed? So all these terms are coming under hood of the descriptive statistics. Okay. So here we can take just like if I say, suppose I want to work on central tendency or dispersion of data in a Jupyter notebook, suppose I want to work. So basically we do have a library for this. Okay, so the libraries are basically NumPy and Pandas. These are the two libraries basically which have certain functions through which we can do the statistics in data science basically. So we can explore those functions inside the NumPys and the Pandas as well to do the statistics here. So if I want to do this NumPy and Pandas here, how we can do? Let's explore them. Just wait. Wait. Let it open first. Let it be open. Now see here, suppose I want to work with the statistics. So simply I will just call import NumPy as NP. So we are having certain methodologies here. Suppose here I can take any NumPy array. Suppose A is a NumPy array, np.array. I can take it and here I can just provide any data. Let me provide any data. You can take any data. Now suppose this one is the data. Let me check it out, the A NumPy array. Now I want to find out mean of this data. So simply I will give here np.mean means numpy.mean, and here I can just give A. So here 26.875 is the mean. 26.875 is the mean of A NumPy array. In a similar way, you can give any other data. Suppose here I'm writing B is equal to np.array, and here I can give any data. You can see, suppose here I'm writing here. The data, you can randomly provide it here. You can see what is the data here. Oh, it is a B here. So you can find out np dot mean of B. So you can find out the mean of the provided data. You can see here right now I'm having number of decimals. If I want to control the number of decimals here, suppose I want to take the results up to here 453.71. So how can I control the number of decimals here? Simply I will take a round function. So inside Python there is a round function. Here I can just write np.mean, that what is the whatever the result is coming, kindly control it's up to 2 decimals here. So here it is control up to 2 decimal. It means suppose here, if I'm taking a round function and here I'm just writing 455.8967. Suppose this is a number. I want to take number up to 0.89 only, means I want to control it up to 2 decimal. So here I can provide the first parameter as the total number with float value, and here comma that how many number of decimals I need. So 2 decimal I need it, that's all. So it will be working here. Okay, it is just taking it as a random wait here. Just wait here. It is just taking actually 8.89 na 89. So when it saw the 9 na, so it make it a full round value for that one. So if I'm writing it here, now see here it is taking, it is making a round value for these given here. But here to control out up to 2 decimal values, so we can give a round function. So here I need up to 0.7. So here it is working. Okay, here. Oh, 455 values coming from nowhere. That one is randomly I'm giving it here. But here this 453 value which is coming, that one is just coming from the mean value. And here the mean is being find it out with a numpy array. So np.mean, mean value of B is being find it out, and we are controlling up to 2 decimals. So 0.7 value is coming here. Okay. So the point is here that we are finding out the mean with the help of numpy array. It means we are doing the statistics into the numpy array. Okay. Now suppose I want to find out the median, the central value. So I can just write here np dot median. So these are the functions provided here. Suppose I want to find out what is the central value in a numpy array, because above I had just created a numpy array. What is the central value? So here I can just give 17. So here it is saying 17.0 is a middle value. That one is a middle value. Suppose here B is there, I created. I want to find out what is the central value here, median value here. So here it is just saying np dot, it is a median value here. Just wait. It is a median value here, median of just wait. So median of B, if I want to find out. So here it is saying 400 is the median value. So what it does basically, this median will make all the data in ascending order and then find out this middle value that will be finding it out here. Just wait, please. Wait. Just wait, please. Okay. So here all the data will be moved into the ascending order, and then NumPy will find out the middle value. So this one is a median. Okay, so mean, median. Now, if you talk about the mod, so basically NumPy does not have a mod function directly. There I would be using some another library. Okay, slowly I'll tell you. Okay, now let's come to the next. Like I told you, in central tendency we do have a mean and median. When we talk about the dispersion of data means here right now I just told you that when we talk about the statistics, statistics is divided into two. the descriptive statistics and the inferential statistics. When we talk about the descriptive statistics, like I had told you, one is central tendency, where I had just gave you like how we can work with the central tendency, mean, median, and mode. Mode I'll show you, just wait, you need to wait. Next one is a dispersion of data. It means how much the data are spreaded actually. Okay. So when we talk about the dispersion of data, so it means we are talking about the range, variance, standard deviation, percentile, skew, and a little bit more are there. So basically range, variance, standard deviation, percentile are major one. So that we can just check it out. So dispersion of data means how much the data are spreaded. So spreading means here, if I talk now, spreading means here, say how much the data are spreaded. Suppose I say this distribution first. If I take this distribution, so basically I'll say the data are not much spreaded. But if I take this distribution, the data are spreaded, and this one more spreaded. And if I take this graph, the data are highly spreaded. So basically now what happens in statistics, basically there are distribution of the data. So see, if I say my data are very less spreaded, so it means my data are less spreaded. My data are less spreaded. But here, if I take a little bit more, suppose here I say, let's take this yellow line. So I will say my data are a little bit more spreaded. My data spread are there. And if I take a little bit more, so I'll say my data are too high spreaded. Spread means how much data point is far away from the mean value. Okay, in a very simple term, suppose here, let's understand very simple things only. Let's say, just wait, please. Just wait, please. Just wait, please. Ayman, just wait, please. Just give me a moment, please. Wait. Give me 1 minute only. Just wait, please. One. Okay, so wait, fine. So here, let's take a simple data here. Suppose here, uh, let's assume, suppose here, I'm having three sections. There's a class, I'm having three sections, section A, section B, and section C. Let's take, there is a class and there are three sections. So there a random test has been conducted. Let's assume. Okay, so there is a random test has been conducted, and into the random test, let's say, here into the test, suppose mean value and the standard deviation values are coming here. Let's say mean value is 50. Okay, means in all these three sections, a test is conducted. So their mean value is 50 in all three sections, but the standard deviation is plus minus 10 in section A, plus minus 20 in section B, plus minus 30 in section C. So what does it mean? It means that suppose that I'm plotting this graph here. So let's assume I'm having a value 10, 20, 30, 40. Here, this one is, let's say 50, then 60, 70, 80. These are certain marks. So what I'm saying here, the mean values are 50 in all. So what I can do here, I can take this line. The mean value is 50 in all these three sections, but the standard deviation is a little bit different here. So here I can say, suppose, let's take, suppose mean in section A, the student achieved marks with mean value of 50 and the standard deviation is plus minus 10. So what does it mean? Mean value is 50, mean is 50. Okay, but the standard deviation is plus minus 10. So I'm saying standard deviation is plus minus 10. So it means plus 10 this side, minus 10 this side. It means all the marks are between 40 to 60. 40 to 60. So their range is what? Maximum minus minimum. Range is what here? Maximum minus minimum. So here range is like maximum is 60 marks and minimum is 40 marks. So it means all the students achieve marks between 40 to 60 because standard deviation is plus minus 10 here. So here range is 60 minus 40. Okay, range is 60 minus 40. So that would be the range that all the students achieve between 40 to 60. Now, if I talk about section B here, so in this case, mean value, mean marks is 50, but the standard deviation is plus minus 20. So mean marks is 50, but the values are plus minus 20 here. Means here standard deviation is plus minus 20. So 50 plus 20, plus 20 you can take. So it means if standard deviation is plus minus 20 in section B, so it means mean value plus 20. So 50 plus 20 this side and 50 minus 20 this side here. So it means all the students achieve marks between 30 to 70. So here the range is higher. It means maximum marks achieved by student is 70 and the minimum marks achieved by student is 30. So it means range is what? 70 minus 30. And here the range is what? Here the range is 60 minus 40. Okay. So this is there. So here, if I say the range is 20, 60 minus 40 is 20, and here 70 minus 30 is here 40. So here the range is what? 40. So here basically range is high, means spread of the data are high. And if you take this one, suppose here in section C, the student achieve mean value of 50 and standard deviation of plus minus 30. Okay, so here standard deviation plus minus 30 means here standard deviation plus minus 30 means you take this value of mean value and plus minus 30 we can take it. So it means 50 plus 30 that is 80, and 50 minus 30. So that is 20. So it means this, the spread of the data is between 20 and 80. So it means highest marks achieved by any student in section C is 80 and the minimum is 20. So if you calculate the range will be here 80 minus 20. So the spread of the data is high in section C because range is what? 60. But in section A, this one, range is, the spread of the data is very low because the range is 20 only. Because standard deviation is very low. Here, the standard deviation is very high here. Okay. So in this way, the spread of the data are there. So basically, this is a dispersion of data. How much the data is dispersed. So if I talk about section C, suppose section C, so here I can say the spread of the data are too high. Suppose this one I say, or here I can say the spread of the data are too high. Okay, how we can do it all in here in Jupyter Notebook with the help of NumPy library. So basically inside the NumPy library, we do have, yeah, we can say, of course, the students are good in studies if they are having a less range, means all the students are having nearby marks here, that we can understand here. Okay. So how we can do this? So here we can say NP dot variance. First of all, let me check out the, suppose here I can take this B data. Let's say B. I can find out here in B, what is the maximum data, what is the minimum data, so that I can find out the range. So let's say I want to find out range. So maximum minus minimum. So here I can find out B dot minimum value. I can find it out 100. So in this data, 100 is the minimum value. B dot maximum is basically this value. Okay. Got the point here? Huh? P dot max and P dot min is there, right? And after that, we can say here, if we want to find out the range here, so range is, I can give here R as the name also, does not matter. I can give here B dot max, just wait here, max minus B dot min. So P dot max minus B dot min, and here I can find out the range. So range is basically 899. So it means 999 minus 100 is 899. So it is saying in this provided data, the range is 899. Okay, so we are finding out range. Now, if I want to find out that inside this data, what is the variance basically? So here in NumPy, we do have a variance. So I can just write here NP dot var variance, and here I can give B. Means this provided this NumPy array I can find out. So automatically it will be finding it out the variance. And if I want to find out the standard deviation, so NP dot standard deviation, here I can just give any NumPy array. This is standard deviation. So NP dot var is a variance, NP dot STD is a standard deviation. Okay. So this is there. Okay. If similarly I want to find out A is there, I just created a NumPy array. So I can take that, one can find out A, and one can find out NP dot range, one can find out, NP dot var, one can find out A variance, how much is the variance into the data, NP dot STD of A also, one can find it out here. Okay, so that we can do it here. Fine. So in this way, like here we can find out the range, variance, standard deviation, mean, median. We can find out with a numpy array. Okay. Now we are having percentiles also. You have studied about the percentile during the Excel. So how I can find out the percentile basically in numpy array. So what I can do it here, np dot percentile, we can find it out. So np dot percentile, suppose here I'm just giving a. So if I want to find out what is the 25th percentile, so here I can give the number, numpy array, and here I can give that what percentile I want to find out. Suppose 25th percentile I want to find out. So here it is saying 9.75 is the percentile in a numpy array. Or suppose here I want to find out 50th percentile. So here I can just give the number to which I want to find out the percentile, and here how much percentile I want to find out. So 17 is the percentile here. Basically, when we calculate the variance here, so this is the formula of the variance you already know. Already everything has been taught in your Excel here. So here the variance is going high because the data are squared here. The difference between the data point and the mean are squared here. That's why variance are very high there into the data. But here later on, because the things are squared, that's why variance are very high. But when we check out the standard deviation, that one is the square root of the variance, basically square root of the variance. So that's why your just wait here. That's why your variance is, sorry, your standard deviation is down here, you can see. So here square root of variance, we do it here. So standard deviation you are getting. So it is not very high. It is not very high actually. Okay. Wait here just. So this one is a percentile here. So when we are talking about the np dot percentile here, when we talk about the deviations, deviation should be less. Deviation should be less. So it means when deviation is less, so it means the data are not spreaded. See, basically, see here, suppose here, I'm saying, if I see here, the deviation, suppose this is a mean value, suppose any mean, it could be any mean value. So here I will say the deviations are less. So that is good. The data are not spreaded high. But when we talk about this one, so here this green line you can say, so here I can say the deviations are high. So the data spread are high. Data spreading means number are far away. So there should be less deviation. That is much better. That is much better. Okay. So np dot percentile, if I want to find out percentile, 25th percentile, so here I can put the number and here I can find out the 25th percentile. Here I can put any numpy array and here I can find out 50th percentile. Suppose I want to find out 75 percentile. So here I can just give percentile, numpy dot percentile. Here I can give any data numpy array and here I can just find it out 75 percentile. And 100 percentile you can find out 80th percentile. So whatever percentile you can find out, you can give into the second parameter. Suppose here you are taking a B, because B also number area I had created. Suppose I want to find out 60th percentile. So simply I can find out the 60th percentile because B is also I had created here B. So if I want to find out 60th percentile, this B, so simply I can give it. Okay, so in this way I can find out percentile. So basically this is overall for the NumPy, that how we can do the statistics inside the data science library, NumPy as well here. This one is a very simple thing I'm talking about. Similarly here, just wait. Okay, suppose here, just wait before it now, wait. Okay, so just wait here. Okay, just to see this one first. Suppose here I want to do statistics with the help of pandas, with the help of pandas. Suppose I want to do the statistics with the help of pandas also. So with the help of pandas also, I can do that. I can take a heavy data, any data set I can take, and I can start doing, I can find out the mean, median, percentiles also in pandas also. So you can see, suppose import pandas as PD, I'm doing it here. I just loaded one of the files, studentmarks.csv. Already I feel you had just loaded this file during your when you were studying about the visualization. At that time, you had loaded this file, studentmarks.csv. So here I'm taking this file here. Okay, so here I'm taking all this file. So studentmarks.csv. Now here inside this file, there are a lot of columns are given there. So inside the column, suppose you want to find out what is the mean marks in maths, what is the mean marks in chemistry, what is the mean marks in bio or any other subjects. So you can pick that column basically. Okay, so that also we can do that. Just like I had loaded this data into the data frame. So here I'm writing df maths, means here inside the data frame, you select the column dot mean. So here, suppose I want to find out what is the mean, what is the mean marks in maths. So in df maths, mean here, find out the mean value of maths marks, find out the mean value of English column. So any column you can take and you can find out the mean marks and any of the subject you can take, chemistry, bio, any of the subjects you can take it. So here I'm just calculating the mean and median also you can calculate it, median. In pandas, we have a mod function directly. In NumPy, we do not have a mod function. So here we are having a mod function. So directly I can find out, suppose I want to find out what is a mod. Mod means which number is appearing the highest number of times. So df maths mod, suppose I want to find out, suppose maths column is there, which number is appearing most frequently. So here I want to find out df maths.mod. So here it is saying 55. 55 is appearing number of times. It means many of the students have 55 marks. In physics, maximum students achieve 96 numbers. So it means we can find out mean, median, mod directly in pandas, but mod function is directly not available in NumPy. Okay, so directly in this way, I can do certain statistics, very basic statistics, descriptive statistics in pandas as well. Okay. Now, okay, you can see here, I'm just writing here statistical summaries also, df.describe. So df.describe function also provides you statistical summary. Statistical summary here, it will be giving the count, mean of all the provided columns, standard deviation of all the provided column, minimum of all the provided column, 25th percentile, 50th percentile, 70th percentile, and maximum percentile. So basically here, in all the provided column here, Means here, whatever columns we do have, so this df.describe will be finding it out entire statistical summary, including mean, standard deviation, minimum, maximum, as well as percentile. So here it is showing 25th percentile. Like 25th percentile of maths is 54, 25th percentile of physics is 56, 25th percentile of bio is 54, or 50th percentile of chemistry is 78, 50th percentile of history is 69.5, or 75th percentile of bio is 87, or 75th percentile of physics is 93.7. And these are the maximum numbers. Like somebody has achieved maximum numbers in English is 89. Somebody has achieved in civics, maximum marks is 89. So in this way, and these are the minimum numbers. Okay, so these are them. Now let's go. There is one of the very important library. That one is just wait here. Just wait, one more thing here. Okay, just wait. See here. Suppose here I'm working in Panda's library. I want to find out the I want to find out variance. I want to find out variance also. So variance and standard deviation with the help of Pandas. So simply I can just write it here. df column name dot var. Okay, so df mass dot var or df mass dot standard deviation, that I can do that. Okay, so variance, standard deviation, I can find it out in this way. So simply data frame column name dot variance or standard deviation, we can do that. So it means with the help of NumPy and Pandas, we can find out all these value variance, standard deviations. You can find it out. There is suppose here, I want to find out, let's say, I want to find out range with the help of range with the help of range. I want to find it out, suppose. So what I can do, I can find out the maximum number and the minimum. Suppose I am taking maths column. I want to find out what is the range in maths, maths column, maths marks. So here simply data frame maths means column name. You can take dot maximum. So maximum will be providing you the maximum marks in maths, in max and variable. So it is saying 96 marks is the maximum mark and the minimum marks is 25. So what is the range? Maximum minus minimum. So maximum minus minimum. R is the maximum minus minimum. So 71 is the range. So in a similar way, suppose here you are having a chemistry marks. So you can write here df chemistry dot maths, df chemistry dot min, and you can find out the variable and that maximum minus minimum you can do. So in this way, you can find out the range as well. So range, variance, standard deviation, mean, median, mode, you can find it out. Inner here, okay. So here, suppose I say, in when we talk about percentile, so in Pandas also you can find out percentile. So in Pandas, what you can do, df maths dot quantile method. Basically, when we talk about percentile in Pandas, so directly you can give data frame column name dot quantile method. Quantile is almost similar with a percentile. Quantile, and this one is the same. Just in this particular maths column, find out 25th percentile. In this particular maths column, find out 75th percentile. So in this way, we need to provide it in Pandas. Quantile is just like a percentile. So here it is just saying like Q1 is holding the 25th percentile, Q3 is holding the 75th percentile. Okay. So in this way, I can find out the quantile also. Quantile is just like the percentile here. Here, now let me show you. Suppose here, we are loading this library from GitHub. In GitHub, there are certain libraries are there. In GitHub, there is a, in GitHub, there is a library. You can find out all the CSV files in the GitHub basically. Call them from GitHub and you can load it here in Jupyter and then you can load it here. Let's take here. I am taking one of the file from GitHub. Let's say in GitHub, you can find out dataset 1. Students, can you do one thing? Go to dataset 1 and try to find out president_heights.csv. Just to tell me, are you able to find out president_height.csv? This is one of the CSV file which is present in github.com, dataset 1. And there you can see there's a file president_heights.csv. Inside this file, various US presidents' heights are present here. Okay, you can find out the name and the correspondingly heights are also present there. So I can take this file and I can load this file here. Just to check it out, data set 1 here. Are you able to find it out? Quantile is similar to percentile. Quantile is similar to percentile. Quantile in pandas, percentile in numpy. You are able to find out the file president_heights.csv. Okay, good. So when you are finding it out file, we can load that file now. So here a lot of previous presidents' names are there and their correspondingly heights are there. What we can do, I can find out mean, median, percentile, range. We can find it out for this heights. So I loaded into this one into the data variable, data. And here, because you can see one more thing here. See here, when you are loading it here, what is the column name here? Height is the column name. So how can I fetch it? Data is this one, data frame name. You can give any other name, that is your choice. And here I can just give height, this one height. So here I can take a data height, okay, so that I can take it. So I'm just loading it here. And now I am finding it out all the mean, median, mode. So data frame name, height, this I'm giving it here. Here I'm just giving it into the heights variable. Heights is a variable. Then heights.mean, heights.standard deviation, heights.minimum, minimum height, maximum height, standard deviation of the height, mean of the height is also provided here. Okay, so that is there. So you can find out entire statistics, central tendency, and the dispersion of the data here. And here, suppose I want to find out 25th percentile, 75th percentile of the median value. So simply you can give heights. Heights means this is the variable I created. So heights.quantile, 25th percentile, heights.quantile, 75th percentile. So that will start giving you that what is the height of the president coming into the 25th percentile and the 75th percentile, heights.median as well. Okay, so this is there. Okay, and if I want to have a visual presentation for the provided data heights column, simply I can call matplotlib here, import matplotlib.pyplot as plt. And here, suppose I want to find out histogram here, so you can see it here, plt.hist, title, x label, y label, I just start putting it here. So here into the histogram, just I loaded the heights, and heights is a variable which I had to get here. From here, I'm just taking it. This one. This one. So in this way, we can just work very basic things. Here I can work. Up to here, the things are clear. You can just raise hand. That basic things are clear to you. You can just raise hand only. That's all done. This is easy for you. You can do it on your own very easily. Very good. Very good. Okay. Good. All good. So this is quite easy. You can do that. So these are the very basic things I'm telling you. Now there is one of the library, SciPy library. Okay. Scientific Python library. SciPy library. This is very important library. It is known as the Scientific Python library. This one is all open source. So basically, these are all open source library. Like here, you can see here, SciPy library here. This one is a fundamental algorithm for scientific computing in Python. So basically, SciPy provides algorithms for optimization, integration, interpolation, eigenvalue problems, algebraic equation, differential equation, statistics, and many other classes for the problems here. It is an open source library here. SciPy is a high level syntax, makes it accessible and productive for the programmers or any background or experience level. So basically here it is saying SciPy wraps highly optimized implementation written in low language, Fortran, C, C++, and many other things. So basically, SciPy library is very good library, very probably very important library, scientific Python, which can do all these things, algebraic equation, differential equation, and statistics also. So if I want to work with SciPy, so basically, means a lot of engineering, mathematical and engineering calculations, we can do it in scientific Python library. So basically, when I talk to the SciPy and I want to work with the special functions in statistics. So what I can do, I can use, there is one of the, inside the SciPy library, there is one of the module here, stats. Inside it, I can find out mod functions. So here, direct functions, I'm having a mean, median. Let me check it out. Mean, median directly into the scientific Python. But if I want to work with a mod, so I need to go in scipy.stats. I need to move, and from there I can fetch it out the mod function. So here you can see numpy.array. Okay, so here I just loaded the SciPy, import SciPy, import here you can say import SciPy, scientific Python library. I'm loading NumPy warnings also, scipy.version. If you want to check it out, simply you can write library name dot underscore version underscore. Okay, now here I'm just providing one of the NumPy array. These are the NumPy array. Any NumPy array one can provide it here. Okay, two-dimensional array you can provide it here. I want to find out what is the mean and median. So here I can just directly find it out. You can see here, just like scipy.mean, scipy.median, even scipy.variance also you can find it out directly. So it means in scientific Python library, we have mean, median, variance, as well as standard deviation also we have. Okay, that you can do that. I'm just doing here because here we are having multiple decimal after decimal value. I want to control up to 2 decimals, so here I just given round function. Okay, this one is there. Now let's see how I can work with a mod function. So mean, median, variance, standard deviation directly we can work with. If I want to find out SciPy mod function, so basically, directly I cannot access it. Just like I told, directly mod function is not available. That is available in scientific Python dot stats. Here it is available. Inside the stats library, I am having a mod function. So here I can check it out. So here I will just write import scipy.stats because I have to reach up to here, this level. So here I just make the alias st.mod. I can write it now. st.mod because this is a st.mod here. So here I can write here st.mod and p value here I can write it. So this one. Now here, if I want to provide any data, okay, here I want to provide any data here, you see here. So mod is, you have to check that which number is coming on the highest. Suppose 5, 5, 5. So 5 is coming 3 times. So what is the count? 3. So here it is saying mod is array 5. It means 5 is the mod here because number of times mod is appearing. 5. 5 is the highest count. And what is the count? So here it is saying 3 times 5 is coming. Okay, so in this way, we need to interpret the data. So this one is entire mod. Okay. In scientific Python, we do have percentile of score also, just like I'm using an NP percentile or pandas.quantile method. So here in SciPy, scientific Python, if I want to call percentile, so here I need to call from scipy.stats import percentile of score. So that I need to call it here. I'm just calling from scipy.stat input percentile of score. So this will work for the percentile. Percentile of score of any provided column and name here I'm just providing. I want to find out the 25th percentile of maths, so that is 10. I want to find out 60th percentile of maths, that one is the percentile of score here. I want to find out 75th percentile of score in English subject, that one is 16 marks. I want to find out what is the 60th percentile in biology, that is 50. So basically here it is showing this percentile of score. Okay. Just wait here. Up to here, the things are clear to you? Okay, so up to here, the things are clear to you? Fine. Percentile of score is basically a function inside SciPy. Inside SciPy, it is there. We cannot write percentile only. Percentile of score is a function name inside SciPy, so it is mandatory to write it. Percentile is available in NumPy. Percentile of score in SciPy. It is a function name actually. Now let's see. No, we need to import here. Okay. You can just import this line only. Wait. For import line is required. No? If you want to do, if you want to use a SciPy, how can you use that? Only you can write a one line. Okay. You can just remove this line. You can write here from scipy.stats import percentile of score directly. Also, one can write it. Got the point here? You have to call, na? I'm saying from scipy.stats import percentile of score. You have to import it somewhat somehow. And in case suppose you're writing here, if you're writing here, import scipy.stats, let's say, as st. Suppose you're writing. So you need to write here then st.percentile, st.percentile. Because you have to provide instance, means you have to provide the alias name as st and then function name you have to provide it here. Just you read it, please. Read it. Take your time and read it. I'm giving you 1-2 minutes. Just you read it carefully. Okay. Just wait here. Basically, we are using the percentile of score to find out the percentile. Just like you are finding out the percentile in NumPy now, you did it into your Excel also. So the same is here, but in scientific Python, it is the name provided is basically percentile of score. Just to revise your percentile, what is a percentile? The same work we are doing it with a function name here, percentile. Okay. Okay, now let's move. When we talk about the statistics now, so here we are working with a lot of data. So here let's take separate certain data, and inside the data, let me create two variables. Variables I'm just making. Variables are what? Basically, variables are the random data we are having into the form of columns. Simple way we can say. So I'm having a variable, suppose here, I'm giving it a variable name. Let's take, there's one of the variable or column name, calories consumption. Calories consumption. And the another variable name is weight. Suppose I'm having two variable as a column. One is calories consumption and the weight. So here I'm having some data. Calories consumption. And the weight I'm having. I can say weight of a person is dependent on calories consumption. Now I'm giving you certain new important term. That one is dependent variable. First of all, I told you what are variables. Variables are the random data provided into the column formats. Just like in data set, we are having various columns. They are basically variables. Variables means column, which are holding the random data. So weight is a dependent variable and calorie consumption is the independent variable. It means the person weight is gained and it depends completely on the calories consumption. Okay. I can give certain new name to it, such as I can give input. Calories consumption is an input and weight is the output here. Okay, so input and output, or I can give it as a X or Y. I can give certain new terms to this dependent variable or independent variable. I can give this one as the explanatory variable. Explanatory variable. Input variable. That calorie consumptions is an input variable or it is an explanatory variable or independent variable. And here to independent variable, I can give it as the response variable, outcome, or I can give the name as the label or the target as well. So it means I can say weight is the target or weight is a label and to the independent variable, which is the calories consumption. This is one of the case I'm taking for just to understand what is a dependent variable and independent variable in terms of statistics. Okay. Now another one, suppose here I'm taking as a example of dependent and independent variables such as fertilizer consumption and the yield gain, means how much field is providing the yield into the like into the fields basically. Okay, how much crop generation we are having. Crop generated in a very simple term, that what is the yield of the crop with the usage of first fertilizer. So if I'm having these two columns in any data set, so I can say that can you tell me the crop generation, that how much the crop is growing or what is the yield? So can you tell me among this fertilizer and yield, which one is dependent variable here? Which one is a dependent variable here? Can you tell me which one is the dependent variable here? Exactly. Right. So you are saying yield is a dependent variable. Exactly. Good. Thanks for responses. And fertilizer is independent variable. Correct. Thank you for your responses. Fertilizer is independent variable and yield is a dependent variable. You can call it as an explanatory variable. You can call it as the input variable. You can call it as the X. You can call it as a Y. You can call it as the label, target, or response variable, or outcome. In this way, you can give few names. Okay. Another one I'm taking. Another one I can take it as the input and the output here. X, Y. I can take it as input and output also, or any label, target. I can take it. Suppose here I can say study hours. How many study hours you are providing to the study, and how many marks achieved. Now, students, tell me what is the dependent and what is the independent variable. Tell me, please, so that I can understand you are learning quick. What is the dependent variable and independent variable? Okay. Correct. Thank you. So you are saying that okay. So according to you, that the I got it. Study hours is independent variable and marks achieved is the dependent variable. Got it. Good. So these are the dependent variable or independent variables are present inside the statistics. Remember this point. Okay. Dependent and independent variables are present inside the statistics. So in a similar way, I can have another variables, another data set. I can take it where I'm having a random variables. Now you think it's suppose here I'm having certain more dependent or independent variables. So here I can say one of the column here I can take, let's say employee name. It could be any name, does not matter. Employee qualification and employee experience. Okay. And here we are having salary. Can you tell me which one is a dependent variable? Simply, you can give only one variable name, which one is a dependent variable here? I'm having 4 variable: employee name, employee qualification, employee experience. Which one is a dependent variable? Okay, good. Thanks for responses. So here you are saying salary is the dependent variable. So I can call here, salary is the dependent variable. So here I can call name as the X1, X2, X3, means these X are input and salary is the Y. So I can give salary as the label or the target as well. Okay, salary as the label or the target as well. So basically in statistics, we do have it. So dependent variable or independent variable, we can take it here. Now, here, let's go ahead with the probability. What is the probability basically? So basically, probability is a chance of happening of any event. Okay, probability is basically the chance of happening of any event. Like if I say by looking outside weather, whether it would be rain or not, again, I will suppose if I'm looking here, very dense cloud. So with that, we can say, oh, okay, 90% there would be a rain. Means I can say there's a higher probability of rain. Just we are looking for the dense cloud. And if sunny weather is there, so no probability for the rain, we can say simply. So probability is just the chance of happening of any event. Okay. Now, certain time what happens, suppose here I say I'm having a coin. Everybody knows in a coin, I'm having a head and the tail. So if I'm throwing up the coin, what is the probability of coming head? So I'm having only two faces. How many faces? Only two faces, head and tail. So if I'm throwing up, so what is the probability of coming head? That is 1 by 2. What is the probability of coming tail? That is 1 by 2. So only 50% chance are there of coming head and tail. So either head or tail, okay? So the point is here, in this case, I'm having only two chances. Either I'm getting a success or I'm getting a failure. Okay, let's say P is a success and 1 minus P is a failure. So I'm having only two events, either success or failure. Okay, that one is a head or tail. Okay, in case of probability, this is one case, right? So whenever we are having only two cases, so we are having a chance of success or a failure only. Okay, so here I can say the events are dependent actually, dependent on each other. Either head will come or tail will come. Now let's say here another case. Suppose I say, suppose I'm taking a case of dice. I'm having a 6 faces. So for getting a like 1, 2, 3, 4, 5, 6. These points I'm having on 2 dice, so 6 faces are there. So if I'm throwing a dice, what is the probability of coming 1? So only 1 by 6. What is the probability of coming 2? So only 1 by 6. What is the probability of coming third phase? 1 by 6, 1 by 6, 1 by 6, 1 by 6. These are the probabilities of coming phases because we are having only single phase for all these. Okay. So in this way, these are the probability of coming different phases. Here, these are the probability of coming phases. Now, there is one point. When we talk about, suppose here I'm talking about the head and tail. Head and tail. So in a coin, head and tail is there. So only two events are there. Yeah. Either head or tail, the two faces are there. So if I'm talking about that, either there is a success or the failure. So only these are dependent on each other. These outputs are dependent on each other. Either one is having a pass or fail. Pass or fail. Yes or no. Head or tail. Only two chances are there. So such type of distribution, if I'm having any data with such type of distribution with only two answers, so I will call such type of distribution as a binomial distribution. Binomial distribution means simply where I'm having entire data with two events only. There's none of the third event is there. So either the success or the failure is there. So binomial distribution, bi means two. Okay, binomial distributions are dependent on each other. All the data are dependent on each other, basically. Now, let's take a case where the data are independent. So it means in case of binomial distribution, the data are dependent on each other and only two cases are there. But let's take a case here. Suppose here I say, I'm having a data related with a mall where that how many customers are coming on a different days. Their data collection I'm having. Okay. So let's say suppose I'm having a data 10, 20, 30, 40, 50, 60, 70. So let's say, suppose I say on Monday, how many people arrived in a mall? Let's say 30 people arrived in a mall. Because it is just a starting of the week, so only weekdays, so only it's Monday, so none of the people are interested to come. So 30 people arrived. On Tuesday, 50 people arrived in a mall. On Wednesday, it's high, 60 people arrived in a mall. In Thursday, let's say 10 or 20 people arrived in a mall. But on, let's say, on Friday, how many people arrived in a mall? So it could be, let's say, higher number of people, suppose 100. Moving about 70, 80, 90 people are arriving in the mall. Basically, the data which is coming, they are independent. Independent means, see, how many people are arriving the mall, that is totally independent. That is nowhere related that on Monday 30 people are coming, so on Tuesday again 30 will come or 20 will come. That is a pre-assumption, nothing can be created because all the number of people coming to the mall is totally independent. So when we are having a such type of data distribution where all the events are independent, so such type of distributions are known as a Poisson distribution. Poisson distribution. So basically, see, whenever I am having all the dependent events on each other and only two events I am having, that one is a binomial distribution. And when it comes to the all the events which are happening, they are independent of each other. There is no connection between each other. There is an independent event. So such type of events are known as a Poisson distribution. Poisson distribution. Okay. Now suppose here I'm having, let's take, suppose I'm having 3 coins. Coin 1, coin 2, coin 3. Okay. Now every coin has a head and tail. Okay, such type of data I'm having. So when I start throwing this coin, so I start making a collection of data that in this, when I'm throwing this 3 coins, how the coins are appearing with the head and tail. Okay, that data I'm having. So let's say, suppose, when I have thrown all these coins, so what happened? Head, head, head came. First time. Then second time again I have thrown, so head, head, tail come. On third time, head, tail, head came. Again, I thrown all these 3 coins 4 times. So head, tail, tail come. Then fifth, it is tail, head, tail coming. Sixth time, it is tail, tail, head coming here. 7th time here. So it means tail, tail, tail. In this way, the data are coming. Point is there that at different number of times, different head or tails are coming. Let's assume. Now, if I want to remember this data, it is not possible for me to remember the data that what had happened, head, tail. It's not possible so easily, okay? So what I'm doing it here, I started picking the random variable. So I collected the information of the head here. So what I'm doing it here, just to make the data form easy, I took that how many, what happened to the head. So 3 into the first event, first time when I've thrown it. So I'm just making all the data which is represented in H&D. I'm going to represent it in number format. So 3 time head, here 2 time head, 2 time head, 1 time head, 1 time head, 1 time head, 0 time head. So I'm just representing all the head in numerical format. Then I make another column here with a random variable. So I'm just calling this column as the random variable here, and I'm calling this column also as a random variable. So here I'm just saying, what about the tail? Tail are 0. Tail are 0. Tail is 1. Tail is 1. 2 tails. 2 tails. 2 tails. 3 tails. So I will call it as the random variables. So basically, These are random variables. Random variable holds random data actually. In statistics, we are having a lot of variables. We are having a data sets. Inside the data set, we are having a lot of variables. Inside the variables, we do have a lot of random values. And then we do treat those values basically. So these are random variables. Okay, random variable is a variable that takes on different values determined by chance. So random variables are having a numerical quantity that varies at random. When we talk about the random variables mean any data it could be. So it is having two types: discrete random variable, continuous random variables. Discrete random variables are having discrete value, just like 0, 1, 2, 3, 4, 5, 6, 89, 24. So discrete values we are having. Okay. But means directly countable values I'm having, like 39, 48. But we are having another random variables with the continuous values. In continuous values, I'm having decimal values, just like 43.4, 58.6. So we can have a random variable in any format: discrete random variable or continuous random variable. Discrete means integer random variable, continuous means float random variable. I can have it in any data set, we can have it. When we talk about the probability, there are certain probability functions. There's a probability mass functions, which will be taking the discrete random variable. And in probability density function, it will be calculating the continuous random variables, basically. In statistics, we do have the dependent event and the independent event. Independent events are those events that don't impact the probabilities of other events. Dependent events are the events that have an impact on the probabilities of other events as well. So dependent and independent event, both type of events we are having in statistics. In statistics, we do have types of distributions also. Just like if I'm having discrete data. Discrete data means I'm having a whole numbers only, 0, 1, 2, 3, 4 in this way. So I can have a certain distribution with the discrete data, such as binomial distribution and Poisson distribution. Okay, so just like I can have a binomial distribution, so I can have either this value, high value, or low value. And in Poisson distribution, we can have multiple value. Independent event I'm having. In a continuous data, when we have the data with a continuous data, so there we can have a normal distribution. Normal distribution is also known as a Gaussian distribution. So suppose here I'm having a decimal values data. Suppose here I want to find out what is the amount of rainfall in inches in a year for a city has came, or what is the random weight of a newborn baby, what is the height of students. So these are continuous values. So we can just make these are known as a normal distribution. So let me tell you what is a normal distribution in detail first here. Normal distribution means here, when we talk about statistics, so there is very important term as a normal distribution. This one is the normal distribution. This one is known as, in the terms of statistics, as the normal distribution. Just wait here, wait. This is a normal distribution. Okay. This is a bell-shaped curve also. Bell-shaped curve. Bell-shaped curve. Normal distribution of the data, we call it. Okay. Now, when we talk about the ideal statistical data, so here, the normal distribution says that in normal distribution, we do have symmetrical data. In normal distribution, when we talk about bell-shaped curve, so in that case, we can say mean is equal to median is equal to mod is 0, mean median mode is 0, and standard deviation is plus minus 1. So this one is the ideal definition of a normal distribution, that normal distributed data are having the symmetrical data. They are basically symmetrical data they are having. The data are having symmetry to each other. And their mean median mode is 0 and standard deviation is plus minus 1. It means all the data are moving between this plus and minus 1 range only. And their mean median mode is 0. So that one is a normal distribution. Ideal curve is there. We could call it a bell-shaped curves also in statistics. Normal distribution means here that the data which we have, that does not have any variations. See, in a very simple word, in a very simple word, I can say that how we can understand the normal distribution. If I say that in this world, entire people have the same opinion, this is an ideal definition of a normal distributed data. It means that there is no variation into the opinions. But this is ideal situation. But what is the actuality? Reality is different. Everybody has their own opinions. So it means the data are distributed. That is not normal. So basically, suppose here, if a class is there and I say 30 students are there in a class, I took a test. So in an ideal normal distribution condition, I will say in ideal data, that all the 30 students has achieved same marks. So that is a normal distribution. I'm saying the ideal condition that all the student has achieved marks, only one marks is here and there. What does it mean? That their mean median mode is 0 because all the students have achieved same marks. Only 1 marks difference is coming here. So it means standard deviation is plus minus 1. But is that true? That is just the ideal condition. I'm saying that all the 30 students have achieved same marks. That was the ideal condition I'm giving. But when I actually started checking paper, there's a lot of variations. So I will say, no, the data are not normally distributed. So here what we can say, suppose this is there now. See, in a ideal condition, in ideal condition, this is a 0 here. Mean median mode is 0. So ideal condition, in ideal condition, here the data would be where mean median mode is 0. But in actually, suppose here I say, but in actually mean median mode is not 0 with the actual data. We do have certain mean, suppose any mean, it could be 30, 40, 50, 60, any mean it could be. So my data are little bit different. So basically, ideal conditions are not existing. But here, this is the normally distributed data which have symmetrical curves, basically symmetry into the data. Got the point here? So this one is basically normal distribution. Now, when we check about the normal distribution curve here, okay. So here we can say data are symmetrically distributed around the mean, median, and mode, or it is also known as the bell-shaped distribution or bell-shaped curve. The form of normal distribution is determined by its mean, standard deviation, mean 0 and standard deviation 1 here. Okay. So this one is a normally distributed curve. Now, basically, in normal distributed curve, there is one of the empirical rule. We call it a empirical rule or 3 sigma rule here. What are those here? So let's understand this data. Basically, what this data shows to you, this is showing you that wait here. Just wait. Just wait. Let me make this, please. Just wait. Suppose this is mean value mu. This is mu. Mu is mean. This yellow line is basically 1 mean plus 1 standard deviation deviated. Here also mean plus 1 standard deviation deviated. Means all the data which is within 1 standard deviation of mean. So how much percentage is there? It means total percentage of entire 68% of the data are lying up to 1 standard deviation in this normal distribution. If I'm taking here, just to see this one, this part here. $95. This total is 95. 95% of the data are lying up to mean plus 2 standard deviation. Mean plus 2 standard deviation, it means this is mean here now. The data are spread up to 95% of the data are spread up to mean plus 2 standard deviation. Here, 68% of the data are spread up to 1 standard deviation. Okay. %99.7%. Listen carefully. 99.7% of the data are spread up to 3 standard deviation. What I'm saying? There is a 3 sigma rule, empirical rule in normal distribution. It says that 68% of the data up to here. 68% of the data lies up to 1 standard deviation. 95% of the data up to here. 95% of the data are lying up to 2 standard deviation. Mean plus minus 2 standard deviation, and 99.7% of the data are lying up to 3 standard deviation. Now the point is, we are talking about, I'm saying 99.7% the data are lying up to 3 standard deviation. Then what is where I'll say 0.3%, 0.3% of the data are gone away. See here, it is saying 99.7% of the data are lying up to 3 standard deviation. That much dispersion is there. You can find it out there in 3 standard deviation. Then where 0.3, why not it is 100%? Where 0.3% has been gone? Where? So here it says, here it says that 0.3% of the data 0.3% of the data are lying. They are here. They are far away from this normal distribution. And those 0.3% of the data are known as outliers. Outliers are abnormal data. Outliers are abnormal distribution. They are abnormal data. Got the point here? It means all the 99.7% of the data are lying up to this is mean, so mean plus 3 standard deviation, mean minus 3 standard deviation. It means mean up to 3 standard deviation, all the data are lying up to here, and any data beyond 3 standard deviation, they are lying here or they are lying here. These data are what? They are outliers. They are outliers. Now, what are outliers? Outliers are abnormal data. Abnormal data. And the data which are lying here, within this zone. This data, this one is the normal data. The data which are in this graph, this one, normal distributed data. So these are normal data and outliers are abnormal data. Outliers are abnormal data means here, let me take an example. Suppose that I say, let's say, right now, entire world is dependent on internet. On internet, there are crores of, I'll say million and billions of websites are there. Hacking of the websites are also going on. Okay, you know that. Basically, what happens normally, suppose you are just doing certain e-commerce, you are searching your products. Generally, what happens? People come on any website, let's say Amazon.com. You are just surfing Amazon.com just to search a product. You want to purchase anything, whichever is your household related, or you want to see any books, you want to purchase any mobiles or laptops, anything I can say. So basically, everybody is moving to Amazon just for the purchasing purpose. You are surfing the website, you are surfing the products. At the same time, hackers are not searching the products. They try to hack the website. So that hacking activity is not the normal data. The points which one is getting with the help of those hacking events, that is not the normal data that comes into the abnormal data outliers. It means the activities of the hackers which are noted, that is different as per the normal person who is just surfing the product. So the hacker activity is abnormal and the surfer is normal. So basically outliers are abnormal data. Remember this point. So here I can say, when we talk about the 3 sigma rule, outliers effect, of course. So basically we can say that in 3 sigma rules, 68% of the data are lying up to here, up to 1 standard deviation. 95% of the data are lying up to 2 standard deviation, and up to 3 standard deviation, 99.7% of the data are lying. Okay, so this one is a 3 sigma rule or empirical rule. But the point is how you would be checking it out. So basically now that to check it out here, outliers or not, there is one of the visualization tool you are aware with, maybe I told you, whenever I want to check it out, the outliers, I can use the box plot. Box plot gives you 5-figure summary. So here now, when we talk about the box plot, it gives you 5-figure summary. So it will be giving you the minimum value of any provided column. It will provide you the maximum value of any provided column. It will also give the 25th percentile of any provided column. It can provide you 75th percentile of any provided column. So here the value of the 75th percentile or 25th percentile will come. And here it will also give you the 50th percentile of any provided column. So basically, I can say like minimum value, maximum value, 25th percentile, 75th percentile, and 50th percentile values will come in. Okay. So these 5 information box plot is giving, and any data which are lying here, they are outliers. Any data which are lying here, they are outliers. These are outliers. So these values are up to 3 standard deviation. 3 standard deviation. Any data which are far away from 3 standard deviation, that is basically outliers. If we want to detect the outliers, we can use the box plot data visualization technique, through which we can understand whether any column is holding the outliers or not. Okay. There's another method of checking it out, the outliers, and that one is basically z-score. There is basically z-score here. In statistics, in scipy.stats, we are having a z-score to check the outliers here. That one is x minus mean divided by standard deviation. Okay, so basically how much the data point is far away from the mean value divided by standard deviation. This one is a z-score. So statistically, or I can say mathematically, z-score is under scipy.stats. If I check it out, this scipy.stat, we can find out z-score and we can calculate it. So basically now, when I talk about the z-score values here, I can call the z-score. So suppose if any data I'm having, if I want to find out what is the z-score value, so here I can just give it, you can see it here. This one is from scipy.stat import z-score. I can give any data inside the z-score value, and here the calculated z-score values is there just by the formula x minus mean divided by standard deviation. This formula is calculated for the z-score. So these are all the values of the various z-score. So it means these 4 formulas are there. I can use scipy.stats, import z-score. Okay. Okay, so this is z-score. I'll just give certain more detail of z-score. Just wait. Now, okay. This is a normal distribution, and this one is a box plot. You can see it here. How we can just understand the box plot, you can see here carefully. Box plot gives us 5-figure summary. This one is a minimum value, maximum value. This point, you can see it is this point, 25th percentile, 75th percentile, median, and between the values of 25th percentile means here 75th percentile minus 25th percentile. The value of 75th percentile minus 25th percentile is basically IQR, interquartile. IQR is the value between 75th percentile and 25th percentile, basically. So if I say here, suppose minimum, maximum, 25th percentile. The value, this range I'm talking about, this is known as the IQR, interquartile. Here it is the minimum value, here it is the maximum value, here it is 75th percentile, 25th percentile, here 50th percentile. And this range IQR is equal to, you can call 25th percentile as a Q1, 75th percentile as a Q3, and IQR is a Q3 minus Q1. 75th percentile minus 25th percentile. Okay. Fine. So suppose I want to find out spread out data that how much is the interquartile in maths marks here. Means see here, maximum marks of maths we had identified. What is the maximum marks here? Suppose 96. So here it is saying maximum marks is 96. Minimum marks in maths is 25. So now this point is 25th percentile or in math subject. And this point is 75th percentile. I can call this 25th as Q1. I can call this one as the Q3. Suppose here I'm just identifying here what is 25th percentile and what is 75th percentile. And what is IQR here? So here, if I want to find out 25th percentile, so simply df maths.quantile 25th percentile, that's 54.25. So this one is 54.25. What is the 75th percentile here? So that one is 70.75, which is Q3. So what is the interquartile? That was the Q3 minus Q1. So it means what is this value? So it means 75th percentile means Q3 minus Q1. So it means 70.75 minus 54.25. Q3 minus Q1, that one is IQR, Q3 minus Q, that one is 16.5. So 16, this IQR is 16.5 basically. Median and 50th percentile are same, exactly. Median and 50th percentile are same. So in this way, we can find out what is the IQR. IQR is interquartile. Okay, so that's there. So in this way, we can just check it out. Box plot, I'll be telling you more in details about the C-score and the box plot. You need to wait. Now let's come here. Right now, if we want to talk about here, See here, when we talk about the normal distribution, the data are symmetrical. And the mean, median, mode is mean, median, and mode. Zero. And standard deviation is plus minus 1 only. This is a case of normal distribution. But certain time, I do have the data skewness as well in this way, or I can have the data skewness in this way also. So the point is that I can have a data in this way, right tail skewed data, or I can have the data in this way also, left tail skewed data. So these are skewness. Skewness means one-sided data we are having. Right tail skewed data or left tail skewed data. So if this is a right skewed data I'm having, so here mean is greater than median. Mean is greater than median in right tail skewed data. And when I talk about the left tail skewed data, here mean is less than median. So this one is left tail skewed data. So this is basically skewness. Skewness means one-sidedness into the data. So now, suppose here I'm having any data which is related to the income of the people. Suppose I'm having a 10 lakh data, 10 lakh rows, which is having the details of the income of the people. So here, if I'm just looking that what could be the data distribution, what could be the income distribution of the people, which I'm having with the 10 lakh people. So if I could be getting in this way, the data are. What does it mean? So here, like $0 to $5,000, maximum people are into the range of $0 to $5,000, and then moving further, very less people are into the band of $1 lakh, $2 lakh, $3 lakh. Less people, but majority of the people I'm getting, that one is $0 to $5,000 or $10,000. Maximum number of the people are there. So I will call it a skewness into the data. So basically, one can find out this one is a measure of asymmetry. Skewness is a measure of asymmetry. Skewness is the asymmetrical in statistical distribution where the curve appears distorted or skewed towards left or right. In case of right side skewed data, mean is greater than median. And in case of left skewed data, mean is less than median. This one is a asymmetrical curve, whereas normal distributions are symmetrical curve. These are asymmetrical curves. When we talk about the global income distribution, so here the curve starts appearing skewed. The curve is appearing skewed, which shows that maximum number of the people are lying into the zone of $0 to $5,000 or $10,000 as an income. So here I'll say the income distribution is skewed. That is not normally distributed. Very less people are getting a $2 lakh, $3 lakh, $4 lakh as an income. For the point here, so this is done. Okay, so this one is, I'll say like, this one is, I just told you about very basic things about the statistics. Tomorrow I'll continue it and you'll be getting more into the depth of it. Okay. That's all for today. Thank you. Have you understood up to here? Basic things only I'm talking about here. Okay. Thank you. Thank you very much. Thank you.